For this example, we're looking for the energy of a photon. And we're looking for the energy of this photon in joules and also electron volts. Now, we can simply convert from joules to electron volts. But first, we need to know joules. So how do we find joules? So whenever we're looking for the energy of a photon, we always need to know what wavelength we're dealing with, or what frequency we're dealing with. In this case, let's say we're dealing with a wavelength of 600 nanometers. Now, in order to find the energy of this photon, we have to do a few conversion factors. So, energy of a photon is equal to h, which is Planck's constant, times frequency. Now, we don't know what the frequency is, but we can find it. We can find it by using the wavelength. So, given the relationship that f has, just a side note, the frequency is equal to c, which is the speed of light, all over the wavelength. Converting that again, you can get c equals to frequency times wavelength. Now, this can come in handy when we combine the two equations. So when we combine this and this together, we get the energy of a photon is equal to Planck's constant times the speed of light all over divided by a wavelength. And from this will give you joules. Now, how do you convert from joules to electron volts? It's pretty simple. Whenever you're converting, you use your joules, your number for joules, because, as you remember, joules can be converted to electron volts. Simply as 1 electron volt is equivalent to 1.6 times 10 to the negative 19 joules. When you put this number in joules and you multiply it, it will give you electron volts. And that is how you find the energy of a photon in both joules and electron volts. You need to know the wavelength, and if you don't know the wavelength, then you need to know the frequency. Once you know both of those, then you can plug and chug.